In the desperate years of World War II, engineers on both sides were under immense pressure to create weapons that could turn the tide of battle. Some of the ideas that emerged from laboratories and workshops seemed to belong more in the realm of science fiction than reality. Yet against all odds, many of these impossible concepts actually became real machines and devices, tested and deployed in combat. This is the story of the strangest weapons that engineers actually built during the war, machines so unusual that even today they seem almost unbelievable. In early 1942, an American dentist named Lytle Adams had an idea that would have seemed absolutely insane to anyone who heard it. He proposed using small flying mammals equipped with tiny incendiary devices to attack Japanese cities. Adams had recently visited Carlsbad Caverns in New Mexico and been impressed by the millions of creatures living in the cave system. He realized these animals could carry small payloads, fly considerable distances, and had a natural tendency to roost in the wooden structures that dominated Japanese urban architecture. Adams managed to get his proposal in front of President Roosevelt himself, and surprisingly, the president was intrigued. He passed the idea along to the National Defense Research Committee with a note saying it was worth looking into. What followed was one of the most unusual military research programs of the entire war. Scientists captured thousands of Mexican free-tailed specimens from caves in the Southwest. Engineers designed miniature incendiary devices weighing less than an ounce that could be attached with string and clips. The plan called for these equipped creatures to be packed into bomb-shaped containers that would be dropped from aircraft at dawn. The technical challenges of the project were enormous. Engineers had to design containers that could be dropped from aircraft and would open at a specific altitude to release their cargo. The timing had to be perfect. Release too high and the creatures would disperse too widely. Release too low and they would not have time to find suitable roosting spots. The incendiary devices themselves were marvels of miniaturization. Each one contained a small amount of chemical explosive with a timer mechanism that could be set to ignite several hours after deployment. This would give the creatures time to settle into attics, eaves, and other hidden spaces in buildings before the fires started. Testing took place at various locations in the American Southwest. Engineers constructed mock Japanese villages with authentic architectural styles. Results were actually promising. During tests, the creatures successfully dispersed throughout the structures, and when the devices activated, multiple fires started simultaneously across the entire area. The advantage over conventional incendiary weapons was that these fires would start in dozens of hard-to-reach locations at once, overwhelming firefighting efforts. But the program faced serious problems. During one test at an auxiliary airfield in New Mexico, some of the equipped creatures escaped from their containment and roosted in various buildings on the base. When the timers activated, they set fire to a brand new aircraft hangar and the personal vehicle of a high-ranking officer. The incident was nearly disastrous. Additionally, by 1943, American military priorities were shifting toward other projects, including the development of the atomic weapon. The program, which had cost over $2 million, was eventually cancelled before ever being used in actual combat, though it had proven the concept actually worked. While American engineers were experimenting with unusual delivery systems, British scientists were tackling an equally bizarre challenge. The Royal Navy was losing ships at an alarming rate to enemy submarines in the Atlantic. Aircraft carriers that could patrol the mid-ocean gap were desperately needed, but steel and resources were scarce. A British inventor named Geoffrey Pike proposed a radical solution that seemed to defy common sense. He wanted to build an aircraft carrier out of frozen water. The initial idea was to tow icebergs from the Arctic and hollow them out to create floating bases. But natural ice had serious flaws. It was brittle, prone to cracking, and icebergs had an unfortunate tendency to roll over unexpectedly. Pike worked with engineers in New York who discovered something remarkable. If you mixed wood pulp with water before freezing it, you created a material with extraordinary properties. They called it pykrete, after its inventor. Pykrete was incredibly strong, comparable to concrete in many ways. It was buoyant, self-sealing when damaged, and surprisingly resistant to impacts. When you shot at it, the material would absorb the bullet rather than shatter. The proposed vessel, codenamed Project Habakkuk after a biblical prophet, would be absolutely massive. The design called for a ship 2,000 feet long, weighing over 2 million tons, with walls 40 feet thick. It would have an internal cooling system running throughout to keep the pykrete frozen even in relatively warm waters. The interior would house hangars for over 100 aircraft, living quarters for thousands of crew, and all the support facilities needed for extended operations. Engineers built a prototype on a lake in Canada. This small-scale model, just 60 feet long, successfully demonstrated the concept. The pykrete remained solid and the structure stable. The technical challenges of actually building full-scale Habakkuk were staggering. Engineers calculated it would require approximately 2 million tons of ice and 28,000 tons of wood pulp. The refrigeration system alone would need a power plant generating thousands of horsepower continuously. Construction would take years even with massive resources devoted to the project. The ship would be so heavy that it could not enter most harbors, and so large that steering it would be extremely difficult. There were also questions about what would happen if the cooling system failed in tropical waters. The pykrete would begin to melt, and once the process started, it might be impossible to reverse. But what ultimately killed Project Habakkuk was not technical feasibility but timing and priorities. By mid-1943, Allied ship production was ramping up dramatically. Conventional aircraft carriers were being built in numbers that would have seemed impossible a year earlier. The vast resources needed for Habakkuk could be better used building multiple standard carriers. The escort carrier program was proving highly effective at closing the Atlantic gap. Additionally, improvements in long-range patrol aircraft meant that air coverage of the mid-Atlantic was becoming possible from land bases. The strategic situation that had made Habakkuk seem necessary was changing. In early 1944, the project was officially cancelled. The small prototype on the Canadian lake was abandoned and eventually melted away. But the research was not wasted. The work on pykrete and ice structures would influence later cold-weather engineering projects, and Pike's creative thinking about unconventional solutions to military problems left a lasting legacy, even if his ice ship never sailed. On the other side of the world, Japanese engineers were developing their own impossible weapon, though theirs would actually see extensive use. They created a delivery system that required no aircraft, no guidance system, and cost almost nothing to build. They would use the jet stream itself as a weapon. Starting in November 1944, Japan began launching thousands of large paper balloons carrying explosive devices. These balloons, called fugo, were ingeniously simple yet technically sophisticated. Each balloon was about 30 feet in diameter when inflated with hydrogen. Attached below was a chandelier-like structure holding sandbags as ballast, the explosive payload, and an automatic altitude control system. The altitude control mechanism was remarkable for its simplicity. It consisted of a barometric switch that would release ballast sandbags if the balloon dropped too low, and would vent hydrogen if it rose too high. This system kept the balloons floating at approximately 30,000 feet as they crossed the Pacific Ocean on the jet stream. The journey took about 3 days. Engineers calculated that approximately 10% of launched balloons would successfully reach North America. They launched over 9,000 balloons between November 1944 and April 1945. The balloons traveled over 5,000 miles, making them the first intercontinental weapons in history. Many did reach North America, landing as far east as Michigan and as far south as Mexico. Most fell in remote wilderness areas and were never found. The American and Canadian governments imposed a complete media blackout on the balloon incidents. They feared that if the Japanese knew their balloons were reaching North America, they might be encouraged to increase production or attach more dangerous payloads. The blackout was remarkably effective. The Japanese, receiving no news reports of balloon attacks, concluded the program was failing and eventually shut it down. The Fugo balloons caused remarkably little damage despite over 9,000 being launched. Most that were found had malfunctioned or landed in areas where they caused no harm. Forest fires started by some balloons were quickly contained. Property damage was minimal. There was only one incident with casualties. On May 5, 1945, a pregnant woman and 5 children on a church outing in Oregon discovered a balloon in the woods. When they began examining it, the device exploded, taking all 6 lives. It remains the only time in World War II that enemy action directly caused civilian deaths on the American mainland. But the Fugo program represented something significant beyond its limited direct impact. It demonstrated that intercontinental range was achievable, even with 1940s technology. It proved that automated systems could cross vast oceans and function reliably. These concepts would influence post-war thinking about long-range delivery systems. The strategic thinking behind Fugo was also noteworthy. Japan was resource poor and losing the industrial war badly by late 1944. The balloon program required minimal materials, mostly paper, glue, and hydrogen. It could be produced by schoolchildren and elderly workers rather than skilled laborers needed in factories. For a nation desperate for any way to strike back at America, the Fugo offered a psychologically appealing option even if militarily ineffective. Today, scattered remnants of Fugo balloons are occasionally still found in remote areas of North America, silent witnesses to one of the war's strangest campaigns. The impossible weapons of World War II represented the extreme pressures that total conflict places on human creativity. Engineers were asked to think beyond conventional limitations, to imagine solutions that had never been tried before, and to build machines that seemed to defy possibility. Some of these weapons worked, some failed spectacularly, but all of them showed what desperation and ingenuity